All right, so let's take a look at section 3.2, some problems from 3.2. In this section, we're dealing with logarithms. And these are a new kind of function. Um, and they're just like any function, you plug numbers into them and you get numbers out after you follow some mathematical rules. Here's what a logarithm looks like. Y equals log base a of x. So that's what your basic logarithm looks like. A is the base of the logarithm, and so we could have any base we wanted with a few restrictions. The base has to be positive and it has to be not equal to 1, just like the bases for exponential functions. In fact, the reason we talk about logarithms now is that logarithms and exponential functions are inverses of each other. They reverse each other. Okay? So what in the world is happening with these logarithms? Um, how do I take the log of some number? So in other words, let's see. Suppose I want to find log base 2. So we're using log base 2. I want to find log base 2 of 8. I know that's equal to some value y. So in other words, what happens when I plug 8 into the log function? All right, what's going to happen there? So here's what you need to know about logarithms, and this is an important thing in order to understand the mathematics. When you have y equals log base a of x, that can be transformed into this expression. This is called the exponential form because we transform the log into the exponential form. So if you want to calculate the log of any number, you need to translate it into the exponential form. So let's practice with that. Let's start with y equals log base 2 of 8. If I want to calculate what that is equal to, I rewrite it in exponential form. So it's 2 to the y equals 8. That's how that works. If you look over here your at the logarithm, you've got a raised to the y equals x, and that's what you get there. All right. So let's write that down for our exponential or for our log base 2. So it's going to be 2 raised to the y equals 8. And now I just need to figure out what value y needs to be in order to make that work. And it's pretty easy to see that y must equal 3. So log base 2 of 8 equals 3. Let's try another one. All right. So let's do log base 3. So we're switching bases of 243. So I want to take log base 3 of 243. That's equal to some value y. All right. So the way to do that is to transform it into exponential form. So 3 raised to the y equals 243. And we want to figure out what power needs to go on that 3 to make 3 to that power equal 243. And if we test with our calculators, we're going to get y equals 5. So we could put a 5 right here. All right. All right, let's try another one here. So let's go. Let's stick with base 3, just so we can see it again. Let's find log base 3 of 27, right? And so we translate that into 3 to the y equals 27. And if we look at that close, we see, oh, it's got to be 3. 3 raised to the third power. So log base 3 of 27 is equal to 3. Right? Plug in a 27 into the function, you get a 3 out. All right, a couple more. Let's find log base 5 of 25. Now, let me show you how I do this. Typically, what I'll do is I'll imagine this. I'll say, well, I need an exponent to go on 5 to give me 25. What exponent goes on 5 to give me 25? And the answer is 2. Don't make the mistake. It's not 5. It's not 5 because it's an exponent, right? So let's try another one. Log base 2 of 16. What exponent needs to go on 2 to get a 16? The answer is 4. Log base 7 of 7. What exponent needs to go on? This little bit where I am putting in these little boxes here. This is the same as transforming it like this, but I don't have to actually write it down. I just do it right there. 5 raised to what power? So that's what I'm doing here. 7 raised to what power equals 7. And so 7 raised to what power equals 7? And of course the answer is 1. Now we can get a little more tricky here. Log base 6 of 1. 6 raised to what power is 1? The answer is 0. Let's do log base 4 of 1/2. Here's a fun one. 4 raised to what power equals 1/2? Well, you have to get, now you got to remember all your rules of exponents, and the answer is going to be negative 1/2. Why is that? Let me write this on the side. Because 4 to the negative 1/2 is the same as 1 over 4 to the 1/2, right? That's what negative exponents. And of course, 4 to the 1/2 is the same as the square root of 4. And 1 over square root of 4 is 1/2. So we have some kind of tricky ones going on there. Let's see, just a couple more. Log base 1/2. Or sorry, let's not do that one. Let's do log base 9 of 1/3. All right, so if I do, that one's also going to be a negative 1/2. And then we'll do log base 3 of 9. 3 raised to what power is equal to 9? The answer is 1/2. So those last few ones are a little tricky because we're dealing with fractional exponents and we're dealing with negative exponents, but those all work. And so we get this whole rich family of functions that do some real interesting things for us. Again, they're the inverse of exponential functions, and hopefully that we'll explore that property a little later on.